The next part that I'd like to discuss is the Lexer, the details about the Lexer class. So let's open Lexer class in our source code. So the semantics refers to issues regarding the logical meaning of the input symbols. So you already know that we're not just taking this input as a string, we actually tokenize all symbols that are supplied within this expression. But beyond that, we now have to assign a true logical meaning to every part, to every token. So the semantics deal with making decisions to store or discard information while processing a sequence of tokens, and also organize the sequence of tokens in a new structure. So the Lexer would understand an expression as a combination of multiplication and addition involving numerical values. Of course, this all sounds like a first-grade math, but what's interesting is that our Lexer will be intelligent enough to make proper decision on how to construct something that can be used to actually compute this thing correctly. So the structure of parse expression internally is represented by abstract syntax tree. So the meaning of this abstract syntax tree is this. So what we have here is we have a tree, and this is the root. So this is the root of our tree. So the root of our tree represents multiplication. So it basically is a token which represents the multiplication operation. So in order to be able to compute this, once this is already in place, we will come in here to the root and we'll ask this root node, what should we do? And this root node will tell us we're supposed to multiply left hand side by right hand side. So then we will say, okay, what is the left hand side? And it happens to be the plus sign. And so then obviously we cannot compute plus by 6. What we have to do, we need to finish this part, and we can tell the plus, okay, do your work. So it will go to its own left hand side and right hand side and add them together and say my answer is 3, because 1 plus 2 is 3. So the left hand side for multiplication is 3, and now it becomes very simple that we can finish the work by multiplying 3 by 6, right? So 3 by 6, and this will be the final answer. So we get the answer that 3 times 6 is 18. So 18 will be the answer as a result of using this data structure, which we call abstract syntax tree, very effectively to represent this expression. So this is the responsibility of the Lexer. Basically what Lexer does in our program, let me resize this, it converts the initial input with the help of the token stream, of course. It converts this input into this data structure that is called abstract syntax tree, that now effectively represents the logical structure of this expression. Okay, so essentially this and this is the same stuff, same parts. You can find every part in this syntax tree in this initial input, but now it's all organized and ready for correct computation. So let's talk about the Lexer. And so the Lexer actually implements a recursive descent parser, which means that it can recursively call its own methods. And this is parser for an arithmetic expression, and the Lexer constructor stores the token stream so that it can start its work with an array of the initial tokens. And typically a Lexer has a designated start rule, which is a top-level entry into the parser. So let's take a quick look. This is the start rule. So what the start rule does, it tells the token stream to tokenize the input. it sets the token stream to the beginning of the sequence of our tokens, and it returns the result of the expression rule. And what this returns is actually the root node of the syntax tree. Okay, so this root node right here is an object that contains this multiplication and references to the left-hand side and the right-hand side, and it's the functionality of the node class. So this is the start rule. Let's take a look at the main method, and I'll just split this view into left and right. So our main method basically constructs the input, and the input is a string builder, and string builder here is just a technicality because the tokenizer uses actually insert spaces, so where possible, to easily tokenize the input, and so we call the validator getString. So we get the string, and the string builder gets constructed from the user input. And this is our initial prompt, this simple angle bracket that we display for the user prompt. We say that if it's a quit that we've got from the input, then we're just going to say bye and exit from the program. Otherwise, what we're going to do is that we're going to construct the Lexer, right? So we're going to invoke the Lexer constructor, and we're going to pass the input, which is string builder instance that already is in place. As we just discussed, we're going to simply call start rule. So we're going to say, Lexer, just do your start rule and give us the result. The result, which is the node, part of the abstract syntax tree, actually this is the root node of that syntax tree, it contains the type. So it has internal type stored, and we can quickly check whether it's an error. So if there was some kind of problem with this input, then we already have an error message that we can report to the user. Otherwise, right now we're just printing the structure of the syntax tree, and we're not doing the actual expression evaluation, but the actual computation will be the first step in our things to do in this assignment. All right, so as you can see right here, we get the AST node, which is the root node into that tree. So basically this result right here, this object result, is what we had in that syntax tree, right? So this result is an object that gives us access to that tree, and of course this root will be the multiplication. So this result that we get from the Lexer is access to this object right here. Okay, so this will be the plus sign in that example, this will be number 6, and this is 1, and this is 2. Okay, so this is the result that we get. We get straight to the root of this abstract syntax tree that the Lexer is going to generate for us. So this input is converted to this syntax tree that supposedly we can use to finish our computation. Okay, so let's go back to our handouts. Of course, our job is to continue discussing the Lexer and how does it do its work. Basically, how does it go from here to something that looks like this.